Next is your IPv6. So IPv4 we have already discussed, right? And there was long time we were discussing IPv6, IPv4. Now we'll discuss IPv6. Okay. So what is the first difference between your IPv4 and v6? Number of addresses. In your IPv4, how many addresses you have? 2 raised to power 32. Because total what is the size here? 32 bit. Here what is the size? 128 bit. So it will be 2 raised to power 128. This is the big number. Okay. And that's why we call it an infinite, because this number is used. Okay. Then what is the other difference? Size 32 bit and 128 bit. Then other difference, octet and hexadecimal, these all differences I have already covered when we were discussing for IPv4. Correct? That in your IPv4 we have octets, in IPv6 we have hexadecimal. Okay. In IPv4 we use dot for the separation, in IPv6 we use colon for the separation. Correct? Then conversion. This thing we haven't covered so far, that how to convert your IPv6 into binary. Okay. So this thing, let me tell you. See, let's say your address is 2001 colon 0db8 colon . This is the address. Now you want to convert it into binary. Okay. All right. So this is one hex state. This is what? One hex state. In one hex state, how many bits? 16 bits. Correct. Now, if this is 16 bit, then how many parts are there? 1, 2, 3, and 4. Correct. 4 values are there. For 16 bits, 4 values are there. That means for 1 bit, how many values? 1 value, I mean, how many bits? 4 bits. Correct. Okay. This I understood. Okay. Now let's say this hex state I want to convert into binary. 2001. This is my first argument. And for each and every value, how many bits I have to write? 4 bits. Now you don't have to do anything. Just one single number convert into binary, as you know, the same method. What should be the binary for 2? Binary for 2 is 1. How? 0, 0, 1, 0. Because we have to write what? 4 bits. Binary for 0? All zeros? Then this is the binary. Simple. Next is what? 0, D, B, 8. Now we know that, okay, 0 till 9, then value 10 is what? A. 11 is what? B. 12 is what? C. 13 is what? D. 14 is what? E. 15 is what? F. Correct. 0. 0, 0, 0, 0. Convert D. D means 13. What should be the binary of 13? 1, 0, 0, 1, 1, 0. Only 4 bits we have to write, right? Only last 4 bits. Then what should be the binary of 11? 1, 0, 1, 1. Then what should be the binary of 8? Do you guys remember or forgot already? I have to convert last 4 bits. No last 4 bits. You have 13. 2, 6, 1, 2, 3, 0. Oh, 13, right? 6 rows. Then again 2. One time. 1, 2, 0, 1. See here. 1, 1, 0, 1. Same method, right? When you have only 2, so only 2 means 2. Okay. One time 0, 2, 0, one time. So only 2 bits are there, 1 and 0. And how many I need to write? 4. So in the beginning, 2 bits, I will make it 0, 0. Okay. So no need to go with the all 8 bits again. Okay. All we need to do, just make it 4 bits. That's it. Okay. For any value here, for any value in any place, the value will never go beyond 4 bits, because maximum is what? F 15. See here. 7, 1, 3, 1, 1, 1. All 1. So value will never go beyond 4 bits. Okay. This is clear. Okay.
The value of the A to F, 11 to 15. It's maximum or the
No. Hexadecimal 16 digits, 0 to 15 only. Right. Confused, huh? So understood how to convert in the binary, right? And whenever you want to convert into decimal, just make pairs of 4. Whenever you want to convert into decimal, just create the pairs of 4. Okay. Let's say the binary given to you 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. So start from right to left, this to this, make pairs of 4. Okay. Now this in decimal, what is this value? 1, 0, 0, 2. Again, back to the same number. Okay. Any doubts? Okay. Binary conversion is clear. Okay. Then next, next we have IP address shortening. Okay. IPv6 shortening method. So let's say your address is 2001 colon 0db8 colon 0010 colon 0001 colon. Okay, let me do one thing. Let me give you the other example. Okay. 0000 0000 Let's say this is your IPv6 address. Now you have to apply shortening rules. The first rule is going to say eliminate starting zeros. Starting zeros from each extent. Eliminate all the starting zeros. Now see here. In this extent, is there any zero in the starting? No. So it will be 2001. Any zero in the beginning? There is 1 0. Remove this. 2 zeros in the beginning. Remove that. 3 zeros in the beginning. Remove that. Here, all 4 are zeros. So only starting we have to remove. So 3 we will remove. Again 3. Again 3. Here also 3. At least 1 0 you will have to keep. Then the second rule. The second rule says replace continuous 0 hex states with double colon. Okay. Now see. Not 0 so far. So 2001 DB8 10:1. Now if you see these three are continuously 0, just replace with double colon and the last text. Okay. Now here you have to take one point. Double colon can only be used once in an address. You can use double colon only once. Okay. So if your IP address is something like 2001:00:00:0, let's say 0010. Let's see, this is your IP address, IPv6 address. So if you shorten it according to the first rule, you will eliminate starting zeros. So this will be this. According to second rule, you would write something like 2001:10:1, right? But now your system will get confused. Why your system will get confused? Your system will get confused that where is 2 zeros, where is 3 zeros. It will get confused because see, it will check that total 8 hex states should be there. Okay. And how many I have? 3. So that means how many hex states are 0? 5 hex states are 0. Now it will, there is a possibility that it will think here is 1 0, here is 4 0. Here is 4, here is 1. Maybe here are 2, here are 3, maybe here are 3, here are 2. Right? So which is the correct option? This one. But if your system gets any of these 3, then the complete IP address will change. Right? So for this purpose, you can use double colon only once. Okay.
So you will read, okay, that is where all the zeros are.
Correct. Okay. So means this is incorrect. What is correct? The correct is either you can write it like 2001:0:0:10, then double colon 1, or you can say 2001:10:0:0:0:1. Now your system will easily understand that okay, total 8 text states should be there. How many I have? 1, 2, 3, 4, and 5. So means how many 0? 3. Here it will check 1, 2, 3, 4, 5, 6. How many 0? So this time the address will be correct. Okay. So your double colon can only be used once. In one IPv6 address, double colon will be used only once. This is clear? Online people? This is clear?
So continuous 3 0 to use double colon, right?
Yeah, continuous 0 hex states you will replace with double colon.
So if you continuous 4 zeros means
Any number 2, 3, 4, 5, any number. If all the hex states are 0, simply double colon, nothing else.
okay.
If all hex states are 0, you can simply type double colon. That's it. Okay.
Okay.
Yeah. Okay. This is not a fixed number that with 2 only, with 3 only. No. Any number of hex state continuous should be 0. That will be replaced with double colon. And
but only one time you have to repeat the double
only
colon.
one time. Just make sure only one time.
Awesome.
So shortening method is clear. Okay. Noted. Next is what? Shortening done. Type of IPv6 addresses. So in your IPv6, we have different types like global unicast, unique local, link local, multicast, and anycast. Like I said, anycast is the feature of IPv6, not your IPv4. Okay. Your global unicast address, these are exactly similar to your public IP address in your IPv4. Okay. What is the feature of public? With the name itself, it suggests global unicast. That means these are globally unique. These are globally unique. First thing. Second thing, these are, if public IP address, that means routable on the internet. Routable on the internet. And how do you identify global unicast addresses? Their range starts from 2000:/3. Okay. This is clear. Then you have unique local. So your unique local addresses, these are similar to your private IP addresses. What is the private IP address? Your private IP addresses, these are unique only in LAN. Right? And these are not routable on internet. And how do you identify? Their range starts from FC00:7. Slash values, slash notation, same thing. How many network bits? Then linked local address. Linked local address, these addresses, you can understand them kind of APIPA addresses. Remember APIPA? Whenever your network interface cannot find DHCP, it will automatically assign an IP address range 169.254. Right? So these linked local addresses, these are also by default automatically assigned. Okay. These linked local addresses, these are automatically assigned to your system. Even if you set an IP address, there will still be a linked local address. Okay. First of all, these are not routable. Means these are not going to go to some other network or something. No, these are not routable. And second thing, these are unique only on the link. These are unique only on a link. What does it mean? If you have a router and 3 interfaces are there. So if there is a link local address on this interface, okay, the same link local address you can have here also as well as here also. Why? Because these are unique only on the link and these are what? Different link. What link local address you have here, that should not be repeated on the other side, but that can be repeated on different interface. Why? These are not routable, so these are not going to go from one interface to another interface. Second thing, these are unique only on a particular link. How do you identify? FE80:10. Okay, means if you see FE80 in an address, that means it is a link local address. Multicast, I don't think I need to explain multicast. One-to-many communication, but not all. Okay, so in the IPv4 we have 2 to 4, and here we have FF00. Anycast, remember, more than one node is going to have same IP address. So these are what? Shared address only. And if you see your Anycast addresses, they are public IP address, same like your global unicast. Same range. So same IP address you can assign on multiple nodes and the traffic will be delivered to the nearest host. These are your different types of your IPv6 addresses. This is clear, guys?
The ranges of global unicast start from 2000.
$:3.
Which starts from 2002.
It means if I'm saying 2000:3, it means that if I write it in binary, it will be something like 0010, then 0000, 0000, right? 0000, correct? Now, how many network bits I have? 3. That means only this part will be constant. So that means up till where I can go, I can start from 2000. This is the minimum. What will be the maximum value? These 3 I will keep constant, and these 3 I can keep until F. Yes or no? These 3, this maximum value will be all ones. So this will be, if this is 11, what will be the value?
111.
Yeah, all 1. 0011. What is the value? 3. FFF. If you see any address that is going between this range, that is your global unicast address. Like this you find. If you say FC00:7, that means F is what? 1111. C is what? 12. Right? 12 means 1100. Then after 00000000. What is the slash value? 7. So that means these much bits I have to keep constant. What? This is the minimum value. So minimum value is what? FC00. Maximum value is what? 1 FF, right? So 1101. What will be the value here? 8 plus 4. So 12. So this will be FDFF. If you see in this range, they are your. Looking at the first hex state only, you will come to know what kind of address it is. Is that clear? So this is how you're going to. Clear? Any doubts? Online people?
No, sir. No, sir.
Okay. Now see, let me do one thing. Let me take one PC here. Taken one PC. Did I do any configuration on this PC? No. Let me open this PC. Desktop, IP configuration. In the IPv6, you see something? Link local address already assigned by default. So how these devices are automatically deciding a link local address? How they are coming to know that, okay, what link local address they are going to use? So basically they are creating the link local address from their MAC address. Okay, so what I'll do, let me do one thing. Let me copy the MAC address of this PC. So fast Ethernet, this is the MAC address. Done. Now see. This is the MAC address. Okay. This is the MAC. Now this MAC, they will convert into link local address. How they are going to convert? First of all, they will apply some rules. First rule, add FF:FE in the center of MAC address. In the center of MAC address and replace dot with colon. Okay. So if you apply the first rule, what will be the center? Center will be here. Center of MAC address is here. Okay. So what I'll do, and I'll replace these dots with colon. So this will be 0, 0, 0, C, colon, C, F, and then in the center I have to apply what? FF:FE. So FF:FE. Then after 04, then colon EA89. So far clear? What I did, this was the MAC address. At the center, I added FF:FE. Okay. If you see, I just added this part, right? And I replaced the dots with colon. That is the thing I did. Now, second rule will be applied. Invert 7th bit. We have to do what? Invert 7th bit. Now, if I start from this side, 4 bits, 4 bits, total 8 bits. So 7th bit will be coming in this part. And when I'm saying invert 7th bit, that means if it is 0, I have to make it 1. If it is 1, I have to make it 0. So first of all, what I'm going to do, I will take this number. I will take my first hex state. Taken, convert it into binary 0, 0, 0, 0, 0, 0, 0, 0. And these two beyond 7 bits, so I'll just keep them 0 and C only. Where is my 7 bit? 1, 2, 3, 4, 5, 6, 7. This is my 7 bit. Right now it is what? 0. I will make it 1. 0, 0, 0, 0, 0, 0, 1, 0, and then we have 0 C. This is as it is. So if I will convert it back to hexadecimal, 0, 2, 0, C. Then remaining address will be C, F, 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 colon, FE, 04, colon, EA, 89. Correct? Now the third rule. Eight, okay, add FEAT double colon in the beginning and apply shortening rules. And apply shortening rules. So first of all, I will add FEAT. So I will add FEAT double colon, then entire address 0 to 0 C colon C F F F colon FE 04 colon EA 89. Correct? After shortening, this will be FEAT 20C C FFF FE04 EA8. Correct? So after shortening, this is the link local address I'm getting. Okay, let's verify. Go to the PC, desktop, copy this. Okay. And then let me paste it here. Do you see? Is it the same address? FEAT, 20C, 20C, CFFF, CFFF, FE04, FE04, A89, A89. See. So this is how the systems, they are creating their own link local address automatically by using their MAC address. Clear? Any doubt? Online people?
No, sir.
Done? Okay. So this thing is done. Conversion of MAC to link local. Features of your IPv6, there is no broadcast traffic. Okay. We have unicast, multicast, but no broadcast. Then auto config for stateless and stateful means address auto configuration is present in your IPv6. Okay. There are different concepts for automatic IP address configuration. So there is two ways. One is stateless and stateful. Stateful is nothing but your DHCP. Okay. So when we consider DHCP for IPv6, that is DHCP v6. And stateless, for stateless, we have one method EUI64. Okay. Second method, we have Slack. Okay. Stateless address auto configuration. And EUI64, extended user interface, something like this, the full form is there. Okay. So in the EUI64, it is going to use the MAC address to create your IPv6 address. Okay. And in the Slack, it will randomly generate an IP address. Okay. So if you see, in case of IPv6, okay, whenever you want to have the address, here we had DHCP option, but what option we are having here? Here. In V4 we had DHCP, but here we have automatic option. Okay. So for automatic creation, they will be using the advertisements from the server routers. The router will be advertising the network. So they will take the network part from the router and remaining host part, they will generate randomly. Okay. Then in case of your IPv6, no NAT or PAT required because number of addresses is already used. But still, if you want, you can perform NAT. Okay. Then your IPv6 has native support for IPsec. This is the protocol, IPsec protocol for VPNs, for providing security to your VPN tunnels. So it has native support for that. Improved header. So obviously, if improvements were made in the addresses, the header is also improved. And it has the Anycast support. Your IPv6 has the Anycast support. So far, any doubt? No? Now let's go and perform routing of IPv6. IPv6 routing is really easy. Okay, before that, one more small concept I'll tell you. That whenever you will take, let's say you apply for addresses, so the ISP will provide you with the /48. Your ISP will provide /48. Let's say you ask for address, they will give you 2001 2001 colon 0db8 colon 0010 double colon /48. They will give you like this. Use this address. Okay. Now in the company you have certain different departments. Okay. So you have to design different networks for that. So in the end host, you will always use /64. This is to make sure. In the end host configuration, we will always use /64. Now, ISP is giving us only 48 bits, and we want how many bits? 64. So what we are going to do? We are going to make subnets here. Okay. 0db8 double colon 0010. So your first network will be 0000. This is your first department. Then second department, third department, fourth department, then fifth department, like this. You can keep on changing, and up till where you can change. So total how many bits you have for manipulation? 16 bits. So means in one network, how many subnets you can create? These many departments you can have in your company. Okay. So out of 128 bit, if we are assigning 64 bit as a network, right? How many bits will be there for host? Another 64 bit. Correct. And if I want to calculate total number of hosts per network, 2 raised to power host bit. So what is the size of your IPv4? And what is the number of hosts in one network here? Right? 2 raised to power 32, 4.3 billion. Move to 2 raised to power 33, already double, 8.6. Then 17.2, 2 raised to power 34. Imagine the number of addresses you have in one network in your IPv6. Correct. Now what will happen? That's why we say unlimited address. You can waste any number of address you want. Waste how much you can. But still unlimited. And we already have all those features like NAT and PAT and everything. So I don't think this is going to exhaust. Okay. So that's why we say unlimited address you can waste. Even for 2 IP addresses, you can use /64, no problem. Out of that, use only 2 IP addresses. That's it. Okay, this is clear. So if you see a IPv4 address, 2001 colon 0db8 colon 0010 colon 0000. Let's say this is your IP address, right? So in this first 3 octets, these are known as network. Okay. These 16 bits, these are for subnet. And then remaining bits, these are for host. Is that clear? This is how. So if you want to do subnetting, just change these values 1, 2, 3, 0, 1, 2, 3, 4, 5, and up till FFF. And in each and every, not just one, not just this network, in each and every subnet, you will have 2 raised to power 64 addresses. Right? So if you see how many addresses you will have here, so 64 plus 16, 70, 80 bits, 2 raised to power 80 addresses you will have in your network if you buy one network from ISP. Is that clear? No, you don't require subnetting. And if you want to just go with a different department, just change these values. That's it. No concept like, okay, you have to calculate a different subnet mask or anything. There is no subnet mask concept, only slash value concept. Only CIDR notation is there, nothing else is there. Okay, you don't have to go and calculate new subnet mask, then you have to calculate that, this and that. No, that is done. We were doing all those calculations there in the IPv4 because we wanted to save the addresses. But here we don't want to save, so no need to calculate anything. Just use any value, random value also you can use, no problem. Okay. This is clear. Now let's perform the routing. And you will see routing is very easy here. Simple, I'll take 2 routers. Connect. Here I'll use 2001 or let's say 2000. I'll use very simple network only, /64. This is the network I'll be using here. Okay. And on the R2, I'll be using some loopbacks. Let's say 2001 /64. Okay, these 3 loopbacks I'll be using here on R2. Okay. Here the IP address I'll be assigning 2000:1. And here I'll be assigning. Okay, sorry, 2000:2. These are the IP address we are going to assign. Okay. If you have done IPv4 properly, your IPv6 is very easy. Now see, go to router 1. No, enable configuration terminal, host name R1. Okay. Interface Z0/0. Now, if I assigned IP address in your IPv4, what was the command I gave? IP address. Then you gave the IP address and subnet mask. The change is anywhere you use the word IP, just replace the IP with the IPv6. Your IPv6 is done. See, IPv6 address. What is the address? 2000:1. What is the subnet mask? Done. Okay. No shutdown. Interface Z0/1. Oh, not Z0/1. How do we check the IP addresses? So what will be the command for IPv6? Show IPv6 interface brief. Just replace the IP with V6. Show IPv6 interface brief. Same thing. See here. What? This is the interface Z0/0. I assigned what? This, sorry. I assigned this IP address, and this is what you see. FE80 means link local address. Okay. So even if you assign IP address, a link local address will still be assigned. Okay. Let's go to R2. Okay, you tell me the commands. Hostname R2. Interface G0 by 0. IPv6 address 2000:2/64. How easy it is. Interface loopback 1. IP address 2001:2/64. Okay. See, V6. Interface loopback 2. Then this will become 2002. Interface loopback 3. This will become 3. Check. Show IPv6 interface brief. All assigned. Gigabit Ethernet 00 assigned. Loopback 1, loopback 2, loopback 3. All assigned. Okay. Now what we need to do? Routing. Okay. First of all, check the routing table here. How do I check? Show IP route, and instead of IP, V6. Show IP V6 route. Same thing. Connected, local, and for your link local. Okay. Now, see, we need to create a route. Okay. And before that, if you want to ping command is the same. Ping 2000:3. You have the ping. Okay. This part is the same. Now define the route. Configuration terminal. What command we used to give? IP route. Here we will give V6 route. Do you see any difference? Same thing is there, same concept. Okay. Now see. IPv6 route, which network you want to reach? 2001:/64. This network and subnet mask I want to reach. What is my next route? 2000:2. Done. To show IPv6 route. See, S code means static. There it is. Let's try to ping. Do ping 2001:2. You have the communication. Default routing you want to do for 2 and 3 both. Okay. IPv6 route. Now, in the default route, network ID and subnet mask part was 0. So instead of typing 8 hex states 0, we can simply write what? : and /value 0. What is the next talk? 2000:2. Done. Default route. How easy, right? Check. Do show IPv6 route. V7. See. Correct. Ping. Do ping 2002:2. This is your static routing and default routing. Any difference you find other than IP and IPv6? Only you have to replace IP with IPv6. The rest of everything is the same. Static routing and default routing is done. So any doubt in your IPv6 concept? Why? This is default. You have to use /64 for assigning IP addresses to the PCs only.
There is value for there is some value for /64 it's random /64.
I showed you, right? The network part, host part. Network, subnet, and host.
Like /3 /8.
Those are the ranges for your classes of addresses, kind of, you can say. That if you want to use public addresses, this range is for the public addresses. If I'm using starting 2001, that means these are global unicast addresses. If I was using different range, FE80, that would be linked local addresses. Okay. So if I use any other range, if I go with FC, that means it is unique local addresses. So these are just to define these only. Other than that, your ISP will be assigning you 48 and you will be using 64 in the clients. Okay. Any doubts? Any doubt in the static routing, dynamic route? Dynamic we haven't done. Dynamic will be there in your IPv6, your CCNP advanced. There you'll see EIGRP OSPF also using IPv6. Okay. Whatever we have discussed, that is the OSPF version 2. Okay. That you will be discussing in more detail in your CCNP routing, and OSPF version 3 that is supporting the IPv6. That will become in your CCNP advanced. Okay.